So, what do you need to set up? There are two main things that you will need to set up as part of following through this course. Firstly, you'll have to set up your Google Cloud account. So, if you haven't, do go onto Google Cloud and go ahead and start setting up. It shouldn't be that hard. It should pretty much just be following some prompts to be able to set up the account, and you'll pretty much just need a few details, which are probably most likely your email, and you'll also need to have a Google account. Most likely you'll not need a credit card. Google Cloud offers free tiers mostly to new users, so you should be able to run on credits for a while and be able to then switch to credit card when it is necessary. So it's an optional thing for you to provide your credit card. Next, you'll have to also set up Google Colab. We'll be using Google Colab at one point, particularly within talking about RAG later on, because we will be using its high performance for setting up our configurations, and particularly in performing embeddings, because it'll take up a lot of RAM. And what I want to do at that stage is that I want to offload some of that performance that we need into Google Cloud. So with Google Colab, you'll be able to do this and use up RAM based on that. So you'll only need a Google account really. So if you already have Google Cloud, it should be pretty much straightforward to set up Google Colab properly. And it should be free as long as you're not using Colab Pro or Colab Pro Plus. Colab Pro or Colab Pro Plus is just an extension of the normal standard free tier of Google Colab. For this course, just doing the free tier should be fine. You can choose to go into the Colab Pro or Colab Pro Plus if you do want to experiment with more heavy workloads, which are most likely going to be above the scope of the course. But just note that you will have to start providing your credit card and start incurring heavier payments when you go into that. So that's really it for setting up, and I'll see you in the next lesson. So, what is Google Gemini? It is a multi-model artificial intelligence model that is developed by Google DeepMind. So Google DeepMind has been one of Google's developers of artificial intelligence, its main developer for artificial intelligence, and it has been able to develop its latest, most powerful model, which is Google Gemini. It is a family of large language models such as Gemini Ultra and Gemini Pro. We'll be taking a look into Gemini Pro mostly during this course. And it's really special because it's able to do much more things that we normally see in an LLM be able to do. Google Bard, for instance, ever since it started being paired with Gemini, is now able to start querying Google Maps or start querying YouTube. And it's also able to analyze videos as well. So there's a lot of use cases that Gemini has, and we'll talk about that in a few slides. You can experiment with Google Gemini within Google AI Studio or by calling it from the API. You can also see it with an action on Google Bard too, because Google Bard has already been integrated to be powered by Google Gemini. So how does this whole thing work on the backend side of things? How it works is that we will firstly, from our application, be calling Gemini, and Gemini will pretty much create a response. So the application will create an invocation which invokes Gemini, and Gemini will come up with a response. The response pretty much will be derived. It'll be sent through back to Gemini, and Gemini will return it back to the application. So more or less, it's just a matter of an invocation and a response created based on Gemini from its backend. And what kind of use cases are we expecting out of Gemini? There's quite a few. Text generation is one of them. Gemini is able to very well be able to create new text based on your prompts. So if you're already a familiar user of other LLMs, you've probably already familiar with just prompting, asking it to generate new chapters for a story, for example, or be able to try to ask it to create different kinds of suggestions based on a particular prompt, and it's able to do the same thing. So it's pretty much on par in terms of that. And content creation is another big thing. So it's able to create new chapters of a book for you. It's also able to create new poems for you. So there's a lot of creative things that you can do based on Gemini that you've also probably already seen from other LLMs as well. Aside from that, it can also do image creation. So it can generate images based on prompts that you provided. It can generate images based on you prompting it, for example, say, create me an image of a dog, for example, or you can also put more descriptive like messages as well as part of that too. So there's a lot of potential for that. Within image and video analysis, this is one of the biggest capabilities I feel that Gemini has, because not a lot of language models are able to analyze a video and describe what's happening within the video. Note that you'll normally need subtitles to be within the video when you do this, but regardless, it's already a very big advancement. And image analysis itself is pretty much it's able to describe images in very good detail. So I feel that video analysis really is the plus point that it has compared to a lot of large language models at this point. And the fact that it can also go into YouTube to search for certain things is a very big advancement to the LLM development so far. It's also able to summarize text, so which is pretty much a standard capability of LLMs at this point. And of course, there's much more too. So one of the things that I didn't mention yet is that it can also do search based on Google Maps as well. For example, you say, where am I located? Or you can say, how can I get to this location? What's the best way to get to that location? So it can be integrated with Google Maps too. And you can see that there are a lot of potential possibilities for that. When you go on Google Bard, for example, you can see all the integrations there. And of course, there's much more that we have not mentioned yet, but definitely it's stuff that we'll see along the way too. Now, why Google's Gemini? Well, it's particularly just because it's a really powerful family of multi-model language models. As mentioned before, it has some capabilities that has not been seen before, for example, like video analysis, at least for most language models that are currently already out. And because it's already embedded within the Google ecosystem, there are a lot of things that you can integrate and access. First, you can look at accessing Google Cloud services. So Google Cloud, you already know that you already have a whole array of services that Google Cloud provides that you can integrate. So you can put it like within functions, you can put it within different use cases, within services. You can monitor based on services within Google Cloud. So there's a lot of potential for integration there. Aside from that, you also have the integrations that they have within Google's other service outside of Google Cloud, namely YouTube or Google Maps. So these are a really great way of being able to integrate with other tools. You can also easily customize models, since they also provide the ability for customizing and fine tuning. You can also look at analyzing images and videos locally and also through the internet. And it's in general a one-stop solution for a lot of things that you can easily get access to and easily just generate content based on. What are some parameters that we will need to take into consideration? Some of them include temperature, top p value, token length, max tokens, stop tokens, and other relevant parameters. So temperature itself is pretty much just a measurement of how creative we want the model to be. It's able to So what are the kinds of parameters that we can expect from an LLM? Well, there are quite a few. Among others are temperature, top P, token length, max tokens, and stop tokens. So let's start off with temperature. Temperature itself is a hyperparameter that controls the randomness of language model output. So a high temperature is able to produce more unpredictable and creative results, while a low one produces more deterministic and conservative outputs. So in other words, a higher temperature can cause the model to be more confident in its output, but a lower one would be able to create more conservative and predictable outputs. For example, if you suggest the temperature to 0.5, the model will just generate text that is more predictable and less creative than if you were able to set the model temperature to 1.0. Top P, on the other hand, is another hyperparameter that controls the randomness of the language model output. It sets a threshold probability and selects the top tokens whose cumulative probability exceeds the threshold. The model is able to then randomly sample from the set of tokens to generate the output. The method can produce more diverse and interestingly output than traditional methods which would randomly sample the entire vocabulary. For instance, you could set top P to 0.8 and it would only consider the most likely words that make up 80% of the probability mass. Token length, on the other hand, is the number of words that or characters in a sequence or text that can be fed to an LLM. It would really vary depending on the language and the tokenization method for the particular LLM, but it's the length of the output input text that will affect the output of the LLM. So a short input text, for example, may not have enough context to generate a meaningful completion, but a rather long input might be able to make the model inefficiently process or may instead cause the model to generate an irrelevant output. So being able to control this is a very important thing. And token length is also related to being able to consider how this kind of process can be made more efficient. Max tokens is a very important thing because it's the maximum number of tokens that the LLM can generate. It's really the maximum number of tokens which can be used in the prompt itself and in completion of the model. So it's determined by the architecture of the model LLM, and each model may have a different definition of tokens. And you need to be able to understand that. And it's usually directly proportional to the computational cost and the memory requirements. So if you set a longer max token, you'll be able to have a greater context being set and coherent output text. On the other hand, if you set a shorter max token, you will have used less memory and you'll have faster output response, but your output will be prone to errors and inconsistencies. During the training and the fine-tuning of the LLM, the max token will be set. So it's really going to also depend on how much you're willing to spend too. Being able to control the max tokens you have is a very good tool of your arsenal because it'll also determine how much you will end up spending and how much you will spend in general. Because you can set a longer one if you feel that you need it, but that would end up perhaps incurring more cost than you would expect. So if you would expect them to instead be, for example, based on 1,000 tokens, then 4,096, then you would need to set a smaller one and save more cost that way that could be incurred. Because in many LLMs and in general for LLMs even, it's really cost is incurred based on the number of tokens that is consumed. Now, stop tokens are the length of the output or response of an LLM. So it would signify the end of the sequence in terms of either a paragraph or a sentence. Similar to max tokens, the inference budget is reduced when the stop tokens are set low. So for example, if the stop tokens are set at 2, the generated text or output will be limited to a paragraph. On the other hand, if the stop token is set at 1, the generated text will be limited to a sentence. There are also many other relevant parameters that would be able to affect large language model performance. And some of these might include number of layers, hidden size, dropout rate, learning rate. So these might affect a model's training time, accuracy, or generalizability. But we're not gonna look too deep into this because we're not gonna really use them. But it's certainly something to keep an eye out for. And if you're interested, feel free to look them up as well and look into them and see where you can use them in your own implementations as well. But generally, if for the most commonplace implementations for LLMs, including Gemini, you'd be dealing with these 5 different parameters. So that's all for talking about parameters, and I'll see you in the next one. Now, there are some things you need to watch out for. These usually include 4 factors: training bias, hallucinations, tracking context in different shifting focuses, and legal and ethical ramifications. Let's start off with training bias. Training bias is the bias that resulted from how the model is trained. So there's been a few infamous cases of AI models in the past being trained in a bit of an unethical way. So for instance, one of the most interesting cases for Google was in their usage of an AI in their hiring process, where it was actually found that their AI somehow always put higher classifications of a better candidate when it comes to male candidates compared to female candidates. And that became quite controversial for a bit. So similarly, with AI such as Gemini, as perfect as it seems it is, there's always going to be potential bias that it can have. And being able to understand that not everything will be perfect is a very important thing. Similarly, on this topic, there also could be hallucinations. Hallucinations are essentially the fact that LLMs might start to make up their own responses when they don't have access to certain data that you ask it for. So for example, you could say, maybe like, do you have data on the financial data for Amazon for 2024? Now, clearly it won't have it, and it can't really look at the internet for that too because it's not 2024 yet. So there's 2 main cases that usually happens. Either it just acknowledges that it doesn't have it, or it will just make up some numbers for that particular implementation you asked it for. So that is what you have to really be careful of. And there are some guardrails against hallucinations, and that usually comes from prompt engineering, which we'll talk about a bit quite in length because prompt engineering is a very important technique that we will be seeing a lot throughout us crafting our prompts throughout the course. Aside from that, we also need to watch out for how tracking context in different shifting focuses takes place. Because oftentimes, Gemini you will have to continually change from one topic to another, perhaps. And sometimes Gemini might not be able to keep up. You might be talking about A, but suddenly you want to switch to B, but maybe Gemini will still think you're talking about A. Or you might be talking about A continuously, but you'll be including some certain facts that you included maybe 10 messages ago. And Gemini might not be able to remember what you said 10 messages ago. So this is the kind of consideration you need to take into account. One of the workarounds of that is pretty much just reminding what you just said to Gemini 10 messages ago when it starts to forget. But then again, there's not really a perfect model for this case scenario. So this is just bringing up for your own consideration. And of course, last but not least, legal and ethical ramifications. There's already been a lot of debate on this. You may have already seen a lot of talks about the writer's strike, for example, or in general, a lot of calls for AI progression to be stopped, and most of that relates to the legal and ethical ramifications that comes with AI. They could potentially create content that might be considered copyright by someone else. So before pursuing something that relates to utilizing AI commercially or going with a particular solution, always be sure that whatever you produce is in line with the regulations. Check up the terms and conditions that provided by Gemini as well before you decide to put something commercially, because everything about this you always need to consider very carefully and ensure that you are not generating something that would be considered harmful or detrimental to wherever you are currently going to be using it. So that's all for things to watch out for. And now let's look at how you can tailor your own use cases. So there are two main ways of how you can tailor your use cases. Firstly, you can fine tune. So we're not going to be talking about this in depth in the course, but fine tuning is basically all about being able to customize your model based on your own data. So you can train your model, for example, Gemini, and try to fine tune it to respond to the data that you've provided it. This is a great way of being able to keep it within guardrails and prevent it from going out and hallucinate too much. But again, we're not going to be talking about that too deep in the course this time around. We can also put context within our prompts. So a really great way of being able to also prevent AI from going off the rails is by providing context. So providing the appropriate context will really help you in being able to control how the AI responds. And this is always a great way of being able to prevent it from going rogue and in general just spouting everything it can. So being specific in whatever you say and ask for is a very important thing. And that's really about it for this particular lesson, and I'll see you in the next one. Welcome to the lesson on prompt engineering. Now, prompt engineering is a very important thing, as I mentioned before, and this is because it affects how our model is able to respond to whatever we put out at it. So what we're going to do is we're going to walk through some best practices of being able to prompt engineer properly so that you can also apply it while also keeping it in mind whenever you see us putting through prompts within our notebooks, and also think about how you would also structure your own prompts and how you could better specify whatever you put forward. But the one key thing that I always want to keep in mind is make sure that they are specific. I think that's the best tip I can give. The more specific you give your prompt to the AI, the better it can be. So, as I mentioned, leading up with that, as some key tips, firstly, be specific, as I mentioned. Aside from that, make sure you provide the proper context. So if you're asking it, for example, to go into A, don't try to say something about B. Like, you need to be able to provide the proper context to it and be able to ensure that it stays within that context. You can't expect an AI to mind read you and expect that it's able to say everything according to what you're currently thinking. You need to provide the proper full context of everything, and based on that, create a prompt that is able to reflect that. Ensure that what you say can be interpreted as an instruction. So you need to ensure that you're instructing it properly. Put it through in a way that can be obtained by it easily instead of just a vague prompt. Instruct it to do something. Be concise and relevant. Don't try to go too far as well in terms of being too descriptive. So when you start to explain too much, it starts to lose a bit of context. Of course, the exception to that would be if you're starting to try work with data and you're putting data, a lot of data that is based on what you currently already have. That's a bit different. But in terms of instructions, don't go around and around because it'll lose the momentum and it'll lose the context of what you're trying to actually focus on. And keep it relevant based on what you already currently have. It's always going to be continuously iterative feedback. So a lot of your experimentations will continually be based on a round trip loop of you asking it to do something, it does something for you, but then you might think, okay, this could be improved a bit. So then you can say, all right, maybe based on that prompt, could you consider these particular considerations and try to refine your response based on that? And it'll accordingly respond based on that too. So it's going to be a continuous iterative feedback process. And this loop will be really what helps build the responses and the further conversations that you have with the model to be more specific based on your own use cases. Finally, just experiment. A lot of this is really going to be continuous experimentation and just really seeing what works. So you're going to be continually just experimenting with the model, seeing how it responds, and accordingly providing it feedback so that it can also improve based on what you're currently telling it. That's really the best way of being able to continually receive the best feedback and telling it to improve based on that. So let's start out by seeing a very simple prompt. We can see, for example, in this case scenario, we are just saying, summarize the following medical article. So as you can see, we're being a bit specific here. Rather than just like dumping article, we're specifically saying summarize the following medical article, and we're just provide instructions. So that's a good way of being able to provide instructions. And this is a great first initial prompt that we can look at. But how we can improve this further? Now, we can do this by incorporating explicit instructions. Because as you can see with this one, we're a bit vague. We tell it to summarize, but sometimes we might have additional requirements. So we put those requirements here. So we then say, provide a concise summary of the following medical article, focusing on the main findings and conclusions, and then we put the article. Why do I put concise? Well, LLMs often have a tendency of going too far in terms of explanations. A lot of it, if you don't keep it brief, it'll end up writing 2 or 3 paragraphs, and that might not be what you want. Of course, unless that's what you want, but you might want, for example, a paragraph summary of something. So that's why you need to include concise if you want that particular specification. Aside from that, if you want to focus on any particular sections of the medical article, you need to also specify which sections you want. So you then say, focusing on the main findings and conclusions. So that way, it doesn't do a recap of the introduction, for example. Instead, brings you to the meat of the article. So it really depends on what your requirements are again. And this is just one example of how that might look like when you start incorporating them explicitly. And this can be applied with anything really. So this is just one use case example that you can also start thinking about as you look into applying your own use case scenarios. You can also provide it sample outputs too. So you can say, for example, here's the article, here's the sample summary, and here's the instruction, which is provide an updated summary based on the article above. So this way, we tell it how the styling should be like. If you have a particular style you want the summary to be in, you can give it a similar summary in a similar style that you want it to be in, and you can ask it to then provide an updated summary based on that. So this way, you can tell it to accordingly adapt that kind of writing style and make it based on that. So this way, you don't have to manually keep asking it to iterate. Of course, this is assuming you have the sample already ready and not that you don't. So this is one consideration. As mentioned, iterative refinement is a very important thing because you can continuously test different prompt structures. You can test, for example, being more specific or less specific or adding detail in a different way. So these are all going to be part of iterative refinement. And a lot of it is pretty much just going to be as simple as just asking it to build onto your prompt. So you can just ask it to, based on your result provided to me, can you start thinking about this too and try to build on it? So that's just one example of being able to iteratively refine based on that. And aside from that, you can also collect the feedback as well on the model outputs. So being able to continuously get the feedback from that, ask it to return the feedback and appropriately provide the feedback back to the model is a very important thing. Finally, let's look at another example of how we can refine another prompt. So we might have a sample prompt, which is telling to correct the spelling and grammar in the following text. So in this case, for example, we're just asking it to proofread. We're giving a text that is filled with proofreading errors. So we can just tell it as easy as that. But how can we further refine that to be better for our use case? If we have specifications, we can start refining it. And instead of just providing a vague prompt, we can instead give a refined prompt, which instead says, provide a corrected version of the following text, addressing the spelling and grammatical errors. So that way, we're providing more context to it. We're telling it what we're actually expecting out of that, and we are telling it the specifications that we need out of just the spelling and grammatical errors in a much better way. So that's an example of being able to continuously refine your prompt. And oftentimes, again, it might not be, you might not even need to write new ones like this. It just might be you providing feedback back to the chatbot, like pretty much if you are currently chatting with, for example, of just saying, based on your previous response, can you also consider incorporating this, or can you try putting this into your response too? Or focus on the main points of this particular paragraph instead of what you've currently already done with the other paragraphs. So just by doing it that way, you can also iteratively refine your model accordingly too. So that's just a bit of a sneak peek into prompt engineering. It's definitely sounds a bit more simpler than it actually is, because a lot of it you will experience directly too when you start making your own prompts. And we'll be seeing a lot of that when we start getting the hands-on of the course. So that's all for now for prompt engineering, and I'll see you in the next lesson.